Hello and welcome to our lesson 19.2 on combined events. If you want to put today's date and the title and pause the video while you have a go at the do now task on the screen. So Sam decides to play a game with his friend Harry. In the game there are two piles of two cards, each with a number on. So the first pile has the cards numbered 1 and 3. And the second pile has cards with numbers 4 and 5. So part A, Sam decides that the rules are you have to pick one number from the first pile first and then one number from the second pile to create a new number. So what are all the possible combinations of numbers you could get? So if you'd picked a 1 from the first pile and a 4 from the second, you'd have got the number 14. Or you could have got the number 15. Or 34 or 35. Part B, if the number picked is even, Sam will win. If the number picked is odd, Harry will win. Is this a fair game? Explain your answers in terms of probability. So obviously the probability of picking an even number is a half, as it's 2 out of the 4 options. So yes, the game is fair, because there are the same amount of odd options as even. So we are going to continue with looking at combined events, and in today's lesson going to look more specifically at sample space diagrams. So we are still working with the same success criteria from last time, so being able to find a basic probability, understanding and recognising when events are mutually exclusive, and being able to work out the probability of combined events. So let's have a look at coins and dice. So if we throw one coin, we know there are two equally likely outcomes, heads or tails. And remember, this is the notation of how we can write it. So the capital P with the event in brackets just means the probability of getting a head or probability of getting a tail. So each of those are equal to a half. So if we throw a dice and a coin, the best way to represent this information is in a sample space diagram like the one we have here. So we have the outcome of the coin on one side and the outcome of the dice on the other. Here it makes sense to put the combinations in separated by a comma. So if I roll a 1 on a dice and then a tail on the coin, or a 1 on the dice and a head on the coin, and then I've got all the different 12 likely options there. So a head and an even number can be achieved in 3 ways. So if we wanted an even number with a head, we could have a head with a 2, head with a 4, or head with a 6. So this would be a probability of a head and an even number being 3 out of the 12 combinations, which is 1/4. Similarly, we can do a sample space diagram for when we are throwing 2 coins together. So 2 heads, so the probability of getting 2 heads is 1/4. Also, we can just look at the options here. So we've got head with a head, head with a tail, tail with a head, and tail with a tail. So to be honest, listing them here makes more sense practically. So the probability of 2 tails is 1 combination out of the 4, so 1/4. Probability of a head and a tail. Now notice there are 2 different ways of getting a head and a tail. So it's 2 out of the 4 options, which is 1/4. Sorry, 2 out of the 4 options, which is 1/2. So there are many situations where 2 events occur together. This is known as a combined event. Some examples are given below, so note that in each case all the possible outcomes of the combined events are shown in the diagram, and these are called theoretical probability space diagrams, or just simply sample space diagrams. So the first option we have here is a sample space diagram showing all of the different combinations if I roll 2 dice, so 2 fair dice. If you don't specifically know what the question is asking you to look at, you could simply list them in this way, where you've got them separated by a comma. The second sample space diagram I have here is actually the sum of the two numbers on the dice added together. In some of the questions it asks for the difference. Remember, this is subtracting the numbers, so what's the difference between the two numbers on the dice, and sometimes it asks for you with questions to look at the product, so this will be multiplying. So this sample space diagram here shows us finding the sum of the two dice. So from the diagram on the right, we can see there are two ways of getting a 3. So we can see we could roll a 2 on one dice and a 1 on the other, but similarly we could roll a 2 on the opposite dice and a 1 on the other. So the probability of getting a 3 is 2 out of the 36 possible outcomes. So the probability of rolling a 3 when you add the two scores on a dice together is 1/18. So from the diagram on the left, you can see that there are 6 ways to get a double. So this layout shows it more easily. So I've got a 1 with a 1, a 2 with a 2, a 3 with a 3, and so on. There are 1, 2, 3, 4, 5, 6 ways of this happening. So this would give a probability of 6/36, which simplifies. This should be 1/6, shouldn't it? So there's a typing error within the example. So it should be 1/6. So have a go now at exercise 19B. I think the work this week is a lot more straightforward than our work on histograms from the previous week, so hopefully you don't have too many issues. I will work through question number 1 with you, so if you want to pause the video and have a go. So Sasha throws 2 fair dice, each numbered from 1 to 6. Part A, what is the most likely score? Part B, which 2 scores are least likely? So let's answer these first. So if we go back to the sample space diagram, now the question was a bit naughty because it didn't actually say to add the scores together. So if it doesn't, just assume that's what they're doing. So if we use the sample space diagram where we've got the numbers 1 to 6 on one side for one dice, the numbers 1 to 6 on the other side for the second dice, we can see here that the most likely score is 7, as this has 6 outcomes for 7, which is more than any of the other numbers. So the most likely score is 7. Which 2 scores are least likely? Hopefully you can spot that the 2 and the 12 are the least likely, as these only occur once. So part C, copy and complete the table to show the probabilities of all the scores from 2 to 12. So for 2 then, there was 1 possibility. For 3, there are 2. For a score of 4, there are 3 possibilities. A score of 5, there are 4. I've done that wrong, I will change that on my presentation. For 6, there are 5. For 7, there are 6. For 8, there are 5. For 9, there are 4. For 10, there are 3. 11, there are 2. And 12, there are 1. Part D, what is the probability of a score then that is bigger than 10? So a score bigger than 10 is just 11 and 12. So that's 3/36, which is 1/12. So the probability of a score that is from 3 to 7 inclusive, you can see I've gone and changed my answer there for the 5, otherwise I would have been incorrect for all of these as well, and you'd have been shouting at me on the video. So from 3 to 7 inclusive. So this is 2 plus 3 plus 4 plus 5 plus 6. So it gives you 20/36, which cancels to 5/9. An even number is 18/36, which is 1/2. A square number, so 4 or 9 for your square numbers. So that's 7/36. A prime number, so 2, 3, 5, 7, 11. So that'll be 15/36, which cancels to 5/12. Now triangular numbers are the number of dots to progressively produce bigger triangles. So the first triangular number is 1. Then in the second diagram, we repeat this one, but then add in 2 to create a next triangle. We then repeat this pattern here, but then we need to add 3 for the next triangle. Repeat the triangle, we have to add 4 for the next one. So 1, 3, 6, 10 are the triangular numbers. So we're adding on 2 adding on 3, adding on 4, so adding on 5, the next triangular number will be 15, which we haven't got here. So we're just adding together the scores for 3, 6 and 10. So this is 10/36, which cancels down to 5/18. So now have a go at the rest of the questions, thinking about sample space diagrams if you need them. And the answers are here when you want to mark your work, and then can you have a go at the Hegarty clips which are listed on the sheet for this week.